which is high above in the preference series. In this series, the group which is on top of this series is given that carbon which contains the group which is on the top of this series is given a number 1 while numbering the carbon atoms, and the one which is below that is then named accordingly, basically is named with respect to that number, that carbon atom. For example, I've given a few examples over here. This first compound, in this case we have two functional groups attached to benzene, the carboxyl group and the OH group. If we look at that series which I've given you over here, the carboxylic acid is much above, is actually above the OH group in this series. So the carbon that has the carboxylic group attached directly is given carbon number 1. That carbon is given a number of 1, and then coming in the clockwise direction to keep the numbering as small as possible, the OH group is given the number 3. So the name becomes 3-hydroxy. The OH group, whenever is a substituent, basically as in this case, whenever the OH group is a substituent, it's referred to as the hydroxy group. So 3-hydroxy benzoic acid becomes the name of this compound. Then the next compound over here, again we have OH group and the halogens attached to the same benzene ring. Referring to the series over here, halogens are below OH in this series. So the OH group is gonna be given the carbon 1. The carbon which contains the OH group is gonna be given the carbon 1, and then 2, 3, 4. I've again come in the clockwise direction to keep the numbering as small as possible. And so the name becomes, now let's specify the position of the substituents. They are identical, so 2, 4 dash dibromo. And whenever a benzene ring contains the OH group, it's referred to as phenol. An OH group attached to benzene is referred to as phenol. So dibromophenol. Then coming to the third compound over here is basically an isomer of the second compound, in which the position of the bromo group has changed. So again the OH is going to be given carbon 1, and keeping the numbering as small as possible, this becomes 3, 4 dibromophenol. Then coming to the next compound, which is again an isomer, the phenol group is given carbon 1. Now it's symmetrical on both the sides, so you can go in either clockwise direction or the anti-clockwise direction. It becomes 2 and 3, 4, 5. So 3, 5 dibromophenol. Now coming to the next compound, again an isomer. So 1, 2, 3, 4, 5, 6. This is the numbering in the anti-clockwise direction, and let's number it in the clockwise direction as well. 1, 2, 3, 4, 5, 6. Now, which of the two numbers are gonna we take? The numbering in red gives us the name 2, 5 dibromophenol, and the numbering in purple gives the name 3, 6 dibromophenol. 5, 2 or 2, 5. if we add them up, basically this is a shortcut 2 comma 5. Okay, just don't add them up, but 2 is smaller than 3 and 5 is also smaller than 6. So basically the numbering in red is correct, and this is our compound 2 comma 5 dibromophenol, and 3 comma 6 dibromophenol is not the proper name of the compound because numbering has to be as small as possible. Then the last compound over here, phenol, is again given the first carbon, then the second, third, fourth, fifth, sixth. So it becomes 2 comma 6 dibromophenol. If I have a nitro group attached to the phenol group, nitro is below OH in this series. So again nitro becomes the substituent and phenol is the root group. The carbon containing the OH group, the carbon which has the OH group directly attached, is given carbon 1, then 2 and 3. So it becomes 3-nitrophenol. Okay. Last part of naming. When is benzene considered a substituent? When is benzene given the name phenyl that we gave earlier, the phenyl group, that we gave earlier? When is benzene considered a substituent? Okay, so these are some special cases when benzene is considered a substituent, and it's referred to as the phenyl group. Then when benzene is attached to a long alkyl chain. Long alkyl chain means 2 or more carbon atoms. So an alkyl chain that contains 2 or more carbon atoms, then it's not referred to as ethyl benzene or not referred to as propylbenzene, but rather is the benzene ring changes and becomes the phenyl group. The name of the benzene changes and becomes a phenyl group, and then the remaining carbon atoms over here, for example, there are 2 carbon atoms, so 2 carbon alkane is ethane, so it becomes phenylethane. So generally the name is written as phenylalkane. So if it were a 3 carbon atom compound over here, so it would have been referred to as phenylpropane, phenylbutane, phenylpentane, and so on as the number of carbon atoms increase. Benzene ring is a substituent. Whenever benzene ring is a substituent, it is referred to as the phenyl group. Okay. The third case when benzene is a substituent, when an amino group, the NH2 group, is attached. Whenever an NH2 group is attached to the benzene ring, then again benzene is referred to as the phenyl group, and the name is written as phenylamine. Then the fourth case, with all alkenes, because alkenes start from 2 carbons. So phenylalkene is the general form over here, phenylalkene. Again, benzene is a substituent, and whenever benzene is a substituent, it's named as phenyl group. In this case, we have 2 carbon atoms, so the name becomes phenylethene. The alkene containing 2 carbon atoms is ethene. Whenever carboxylic acids containing 2 or more carbon atoms, then 2-benzene ring is referred to as the phenyl group, and in this case the carboxylic acid is of 2 carbons, so the name becomes phenyl. 2 carbon acid is called ethanoic acid, so phenylethanoic acid. So that's it. This is how we name derivatives of benzene. Thank you so much for watching, and in the next video I'm gonna talk more about benzene. And basically in the next video we are gonna start the chemical properties of benzene, basically all its chemical reactions of benzene. Thank you. The electrophilic substitution reactions, etc. Okay, thank you so much. Take care.